Hi everyone, my name is Dimitri and this is going to be a brief overview of the threads. So what are threads? A thread is a small independent piece of code that the processor or CPU runs concurrently with other threads. The classical example will be like you have one thread for a main game loop that runs constantly, and you have another thread for a chat system that can accept other messages from other people, and it's going to sit there and wait until something's gonna happen, like receive the data for the chat and display it to you. And one thing to know, like the more threads you have, the more memory you're gonna need because all the threads share memory. Synchronization and mutexes. Like when you have multiple threads in one program, you need to synchronize them. Like notify one of the threads that some data was received for it and it has to do something about it. And to do that, we use mutexes that helps to deal with synchronization. It is essentially a boolean that determines object state, whether it's locked or unlocked. So when an object is locked, the threads have to wait in line until it becomes unlocked in order to access that object and actually do something with it. Semaphores. A semaphore is essentially a mutex, but it allows a certain number of threads to access an object before it becomes locked. So, but like if one of the threads in the object has finished its job, then it kind of signals like that there is a free spot for another thread to access that object. So the thread that was waiting in line takes its place and does whatever it has to do. A conditioned object. A conditioned object has two main commands, wait and signal. So let's say you have a lot of threads that are supposed to do something, but for next 5 minutes or until certain conditions arise, they should just sit there and wait. So the wait command puts those threads into sleep mode, and they essentially wait for that signal command that will wake them up when it's necessary so they could continue doing their work. Excuse me. What are the issues with multithreading? Well, memory. The more threads, again, like the more threads we have, the more memory we're gonna need. So creating like thousands of threads for very small pieces of functions is not recommended because in the future, like it says here, processing power, like the more threads we have, the more processing power we're gonna need because the processor has to calculate each thread to know which one to execute next and etc. So the more threads we have, the more processing power and more time it's gonna take. Deadlocks, like if let's say it happens when object is already locked and we forgot to unlock it and a thread comes in that's supposed to lock it, it's gonna try to access that object and lock it, but since it's already locked, it's gonna be stuck like in a loop and you won't know what to do. So that's a deadlock. And data corruption. We have to make sure that we synchronize our threads, and if we're not gonna do it, the data corruption is inevitable, and also it can occur that the data can be overwritten by other thread if we, let's say, we don't have metaphors. And debugging. Debugging is a very hard process since most debuggers don't support multithreading, but if they do support it, like you can step through one thread that you select, but the other threads are gonna be still running, so you won't be able to keep track of what the other threads do while you're debugging the one that you selected. So now we're gonna take a look at some code. The first one I'm gonna look at is a threadlib functions.h file. So in here we have, like if we're on Windows, these are necessary includes we need, if on Linux it's all this. We also include exceptions. Then We also define the standard thread function format, which takes a void as its parameter and it returns nothing. And like if you're running on Windows, like in order to access those threads, if we need them in the future, we need a thread ID, and also we have to set up some sort of container, which is a map. And in Linux, all we need is just a thread ID. Then we have a class dummy data that has a thread function and a data for it. And also there's a dummy run. Like it says here, this is a dummy thread function that will be used to transparently translate function pointers to whatever system the user is currently compiling on. So as far as I understand, like if you run on Windows, you're just gonna transform in a type of a thread that will run on Windows, and if on Linux, the other way around. Then here we have the main function on how to create the threads. So in the create function, we pass in thread function p function and the parameter of type void. So there we create a thread ID, which can we use, like the thread ID is used for reference in the future if we need it. Then we create a dummy data block. So dummy data, and we make the data function equal to function, and we make the data emitted equals to parameter that we pass in. So if we run on Windows, we have to create a handle. So on Windows, in order to access that thread, we need a handle and the thread ID in order to do something to that thread, like yield it or kill it off if we need to. So we create that thread, and if our handle is not equal to 0, we push that handle into that map that was defined up like before. And in Linux case, we just create the thread. We don't need any like containers or anything. So if our thread is equal to 0, we delete the data and throw an exception, just like an error display if something bad happened to it. Otherwise, we just return the thread ID that was created. So get ID, we just get the ID of the thread that we want. Wait for finish. We just wait till the thread finishes its like whatever function it's executing. Then kill. We force the thread to terminate itself, but it's a really bad thing to do, so do it only if it's complete necessary. And yield thread, we just basically put it to sleep for a second in order to make the other thread to execute like its own functions or whatever. So in threadlib function.cpp, we have again the map and a dummy run. Like as far as I understand, like a dummy run, like it was said before, it just transforms itself into a type of a thread depending on the system you're running on. That's how I understand it. I could be completely wrong though. And threadlib mutex, well, it was explained before what the mutex is. It's just like it defines the object state if it's locked or unlocked for threads in order to like access it. And I have a little example. Well, actually, this example was written in a class that we did before, but the only thing I was actually able to kind of think of to show how a kill function works. So we still have the same print thread, but I just did a little tiny modification. I have a counter here, and when the counter hits like 50 or over it, it should kill thread A. So like, when we're gonna kill thread A, we should actually see more printouts for character B than A. So if we run it, that's what should actually happen. Didn't seem like it did it, but let's compile it again and run it. Well, this time it worked. Like it was said before, we can't control how threads are run or whatever, but for some reason sometimes the kill function doesn't work for me, but this time it seems like to work. So we can see it's mostly B's that are printed out and only few A's. So this is how the kill function works. And yield, you can't really demonstrate yield because it just makes the thread to like sleep, I think, for a millisecond. So can't really show much there because you're still gonna see lots of A's or B's printed out. And wait for finish, it's just like it runs till it finishes its execution. Like in this example, the counter hits 10,000, and that's pretty much it. Thank you.